So we know that the derivative of e to the x is e to the x, something cool about e. And we also know that the derivative of log x is 1 over x. These are the two things that we know so far. Now what I want to do is investigate, well, what would be the derivative of a to the x, where our base is not necessarily e, but just in general. For exponential functions, what is the derivative? And in addition, I want to look at what would be the derivative of log base a of x. So instead of just looking at the natural log and the natural base, let's see if we can figure out what these are. I'll first of all deal with this a to the x. Okay, so here we've got y equals a to the x. Now, what I want to do is I want to utilize this fact up here. I know the derivative of e to the x is e to the x. Well, you might say, well, there's no e in there. Well, let's see if we can make it happen here. Let's write this as e to the natural log of a to the x. That works because e and natural log are inverses of each other, so really this is just y equals a to the x. Now, let's differentiate this. If we differentiate, we'll get dy dx is equal to e to the natural log of a to the x times the derivative of this natural log of a to the x. Well, notice that I could write that this way. I could write log a to the x. I could write that as x log a. Yeah, because that's one of the properties of logs, right? I can bring the x out front. Now, so I'm looking at the derivative of x log a. Well, log a is just a constant. The derivative of 2x is 2. The derivative of 3x is 3. The derivative of log base ax is just log base a. Well, not log base a, just log a. Okay, because log a is the constant. So here's what we have. Now, let me just rewrite this the way it was earlier. And I've got this. I've got a to the x. That's what this is. See, that's what that is. Times log a. That's the derivative right there. So, for example, let's suppose that we have y equals 2 to the x. Well, the derivative then would be 2 to the x log 2, like that. See? Just like that. Now, of course, you can see if this were e to the x, I would say e to the x log e. Well, log e, natural log of e, is just going to be 1. So you can see it works in general. Now we could say, okay, let's look at this. What if we have 3 to the 4x? So we've got the chain rule involved, just like always. We always have the chain rule. And this is going to call for us to use the chain rule. So here we go. We've got dy dx. So this is an exponential function. The first thing I do is just rewrite the function, because that's the first part of the derivative. Then I have to remember, okay, I need to tack on the natural log of the base. But I'm not done yet. Not done, because I've got to remember the chain rule. I've got to differentiate the top. So this is times 4. There. Now that's the derivative. So the chain rule is involved. Now you also have the product rule. Let's suppose that we've got sine x 5 to the x squared plus 1, something like that. So all the rules are still in effect here. We're just learning a new formula for the differentiation of the exponential function. So let's see here what we've got. We've got dy dx, the derivative of the first times the second. Okay, plus the derivative of the second. Well, here we go. 5x squared plus 1. And I'm not done yet. Log 5 times 2x. Okay? See? There's the derivative of the second. I just rewrote the exponential part times the log of 5 times the derivative of the top. Then times the first. See? Derivative of the first times the second plus the derivative of the second. All of this times the first. Yeah, there we go. So this is the exponential. This is the just the general. This is the derivative for the general exponential function, just a to the x. Now let's look at the log part. Okay, let's look at the log part. Now, so what I have is I have y equals log base a of x. And what I want to do is figure out what that derivative is. So let me do this. Let me convert this to exponential form because I just got finished working with exponents. So let me go ahead and convert this. I've got a to the y equals x. Now I'm going to use my implicit differentiation technique, right? So I've got a to the y. I'm differentiating this a to the y times log a. But remember, implicit differentiation, we have to tack on a y prime, dy dx. See? So I just differentiated that. I just learned how to do that. A to the y, log a. Oh yeah, implicit. I got to do the chain rule here, y prime, equals the derivative of x, which is just 1. Okay? Now, what we want is this y prime. This is dy dx. So let me solve for that. I've got dy dx is equal to 1 over, let's see what I've got here. I've got a to the y log a. Yeah, there we go. Now, notice a to the y is the same as x. So here's what I have now. I have dx of log base a of x is equal to 1 over x log a, like that. And notice that if you're dealing with the natural, if you were dealing with the natural log, well, this would be log of e, and you would just get 1 over x. So let's look at an example here. Let's suppose that we have log base 4 of x. Well, dy dx is equal to 1 over x, see, log 4, like that. That's it. Now, of course, as usual, you have the chain rule involved. Everything, you know, all the other rules are still active. So let's suppose you've got 3x here. Suppose you've got 3x. Well, this is going to be 1 over, now, you got to be careful. You're going to put 1 over 3x log 5. See? But you've got the chain rule, so I need to multiply by the derivative of the inside. See? Multiply by the derivative of 3x. And these 3's cancel, and you're just getting 1 over x times log 5. Okay, there you have it.